Right, now we're looking at circular motion and what is uniform circular motion. So let's just have a quick overview of the syllabus connections for the New South Wales students, and let's get our head around, because it's important to understand the relationships and connections between the concepts. So you should have done your mind maps for the first section, and check out the mind map sheet, etc. when it's posted, to try and help you make connections between the concepts. But let's look at circular motion here. Now it says circular motion. The inquiry question is why do objects move in circles? And that's a fairly easy question to answer. And in doing so, we're going to be looking at a variety of things. We're saying, well, why do they move in circles? And that is due to a variety of things. And we're going to be looking at these sort of things here, such as cars moving in horizontal and circular bends, mass on a string, objects and bank tracks. We're going to be looking at a formula to talk about the measurement of a circular force, this centripetal force, and it's dependent on these things here. Then we're going to be looking at some equations. So when something undergoes circular motion, it has centripetal acceleration, and so we're going to be looking at that. We're going to learn how to calculate the speed of the object as it's going around a circle. That's the centripetal force equation there. And then we talk about what's something called angular velocity. So when something's going around, it's going around a circle through an angle in a certain period of time, and so that's what that one is there. What causes things to undergo circular motion? Well, a variety of things, a variety of forces, but sometimes we are pushing on objects to make them turn in a circular fashion, right? And that is something called torque, where we have a force in a rotation. So here is just an overview, and we're going to start off with what is circular motion. So we can see lots of videos playing here of objects undergoing circular motion. We can see planets going around the sun, we can see a car turning a corner, we can see like a ride at an amusement park, and then of course we have just turning a wrench. And so all of those examples are some examples that we have in everyday life where objects undergo circular motion. But for a definition, circular motion is when an object moves in a circular path or along the circumference of a circle in its undergoing circular motion. So it doesn't have to go completely around in a circle like this. It can just turn a corner. So it's going through a circular path. In other words, it's changing direction as a result of a net force. So if we have a look at this tennis ball here, we can see that we've got a string pulling on that tennis ball. And if that string wasn't there, then that tennis ball will keep going in a straight line, according to Newton's first law of inertia, right? Objects that are in motion undergo motion in a straight line unless acted upon by an unbalanced external force, right? So I throw this in space, and this keeps going forever in a straight line. If there is a force acting on that object, and if that force, the net force, is unbalanced, then it will start to change direction. And so here we have a string causing it to change direction, and that direction is resulting in circular motion. Now that's uniform circular motion if the object is having the same velocity, right? And so we can see just a quick little video here of something I did before. We're doing a workshop and a party where and act as the crazy scientist. But you can see here a totem tennis where a ball is on the string and it's just flipping around the center pole there. That's circular motion. The string is providing tension force to the ball, causing the ball to change direction. Okay, here are some key fundamental ideas about circular motion. Okay, and make sure you can explain and identify these, because these pop up a lot of the times in multiple choice questions. First thing is that with circular motion, there is a force that acts 90 degrees to the direction of motion. So here is our direction of motion, okay? But there is a force acting on that object, and that force is 90 degrees to the direction of motion, okay? And when that occurs, the object changes direction in a circular fashion. The next thing to realize is that force causes the acceleration. Remember from Newton's second law, F equals ma, that when we add up all the forces in a direction, if they're unbalanced, then there is a net force acting on the object, and that net force causes an acceleration to happen. Okay, let's say You know, let's say we have this calculator, right? It's resting on my hand. I'm pushing that way. At the moment, the horizontal forces is me pushing that way, the applied force, and then there's friction acting backwards, right? So they're balanced. However, if I push more now with a greater magnitude, I'm overcoming the friction, which means the net force is causing the calculator to undergo an acceleration. Okay, and that's the same with circular motion. And when that acceleration happens, we call it a centripetal acceleration. That is acting towards the center of the circle, and we're going to be learning more about that. So going into the center of the circle is our centripetal acceleration. Another key aspect is the velocity of a ball is constant, then we say we undergo uniform acceleration. Now, if the velocity is constant, how can it undergo acceleration? Because isn't acceleration just the change in velocity divided by time? Well, if it's got the same speed, is its velocity changing? Yes, it is, because its direction is changing. Remember, velocity has a magnitude plus a direction, and the magnitude, that is the speed, might be constant, but the actual direction is changing, so therefore the velocity is changing. So an object going around, let's say a planet going around a central sun, is maintaining a certain speed in its orbit, right? But its direction is constantly changing, so therefore there is acceleration going on. And what do we call that acceleration? Centripetal acceleration. Okay, and so that's something we need to think about as well. Now, there's many types of forces that can cause an object to change the path of its motion and therefore undergo uniform circular motion, and we're going to be looking at those in the next video. So that's a quick introduction of what circular motion is. Hopefully now you should be able to define what circular motion is, that an object is undergoing a change in direction, right, due to the application of a force acting 90 degrees on that object, and that force causes the object to undergo a circular path, like turning a corner, or continue in a complete circle, right? And a complete circle, in this video, we looked at, for example, the Ferris wheel, where you're spinning around in a complete circle. Okay, we had planets orbiting a sun, they were complete circles. And then we had two examples that were just showing a circular path, right? We had a car going around a corner, and we had a wrench tightening a nut. And so all of those were circular motion. You now should be able to explain what we mean by uniform circular motion and some key features. So, as always, make sure that you're in the physics flow, you're constantly focused on the knowledge, and you're revising it actively. And of course, you're seeing the relationships between the videos that we make, between the concepts, and you're doing your flow diagrams. So I'll see you in the next video where we explore more circular motion.